Hello, bro. Am I audible? Am I audible? Roshit, bro.
Yeah, everything is fine. Can start the class.
So, hello, everyone. How are you all? Very good evening to everyone. Very good evening. Hope so. Like your Sunday is good. Okay, fine. Okay. So, hello, everyone. How are you all? Very good. So let's start the today's session with the thermodynamics. Hope so. Like you might have understand the thermodynamics chapter very well, and then these chapters are full of small concepts, and then the all those are formula based chapters mainly. I would like to say, just because like if you are able to memorize the formulas of each and every like small concept, so you will be able to solve the questions very easily. And then believe me, the questions which are coming in the JEE or the needs are very easy questions. Like if you will have a proper like hold on the formulas. Okay, so now let's start the today's session with the previous year's questions, where we are going to solve the questions of JEE as well as the needs. Okay, now this is the first question on your screen. What does the question say is the correct option. Okay, the correct option for free expansion of an ideal gas under adiabatic condition is. So like it is telling about the what? It is telling about the adiabatic condition. So like if you are solving the thermodynamics question, I like what I will suggest is like just distribute the words of the question. If you are distributing the words of the question and try to understand each word of every like of the statements of the question, you will be able to like solve the questions in just in few seconds only. Okay. So what does the question says here is, what does the question say here? Let's proceed. The correct option. First of all, it is telling the correct option. Okay, because sometimes it mention incorrect option. So you have to like proper alert on this. And then what is telling about the free expansion? Free expansion of an ideal gas under what? Under adiabatic condition. So like we have seen that the whenever we are using the word free expansion, whenever we are using the word free expansion, what does the free expansion means? What does the free expansion word means? Free expansion is nothing but the no external pressure, right? No external pressure. If there is no external pressure, then what pressure will be? External pressure will be zero, right? If the external pressure is zero, then we know that the delta, not delta, like work done. What will be your work done? Work done is nothing but the P external delta V. And then if this P external is zero, that means if this term is zero, if this term is zero, then whole this work done will become what? Zero. And here you like you can see in the option is like there are only two options where work done is zero. First is this option and then the second option and then the fourth option. Now let's move on to the another question. Sorry, not another question. Sorry, another word. What it is mentioned here is adiabatic condition. We know that the when there is a adiabatic condition, when there is a adiabatic condition, during adiabatic condition, what we take? Heat. What we take? Heat is nothing but the equal to the zero. Okay. If heat is equal to the zero, that means here how many like options have the Q is equal to zero, that is heat equal to zero. Like among this B and then D option, only D is having the Q is equal to zero, that is heat equal to zero. That means our correct answer is D, right? Hena easy. And how it becomes delta T is equal to zero. Suppose what we write the formula, that is your first law of thermodynamics. What is your first law of thermodynamics? It is nothing but the delta U, that is your change in internal energy, is equal to Q plus work done. If your this is work done, this is zero, and then this is zero, then change in internal energy will be zero. And then we know that the change in internal energy is nothing but the NCV delta T. And if this term is zero, then this whole term will become zero. That means this delta T will be is going to be what? What is delta T? Delta T is going to be what? Zero. Fine. So this is your the correct answer. That is your option D. Okay. Hannah, easy. So let's like what I told you is question are going to be very easy. Just what you have to what you have to do is just focus on word by word of the uh, okay, and then the nothing else. Now moving on to the next question. This is the J question of like April 12, which was conducted on the April 12, and then first is nothing but the first shift of 2019 year. So what does the question here say is, let's read the question. An ideal gas is allowed to expand. What is the ideal gas is expanding. Ideal gas is to expand from 1 liter to 10 liter. 1 liter to 10 liter. That means this becomes our V1 and then this becomes V2. Also, we can tell it as the final volume and then the initial volume against a constant external pressure of what? Against a constant external pressure of 1 bar. Okay. And then here it is asking the work done. The work done in what? Kilojoule. So do you remember the formula? Like how can we calculate the work done? It is very easy. How we are going to calculate the work done? Let's solve. We know that the work done is nothing but the P external and then change in volume. And what does this say is minus, here pressure is how much? 1 bar. So this is 1 bar, and then your work done. Work done, that means delta V. Delta V is nothing but the, what will write? Delta V, that is change in volume, that means V2 minus V1. So here your will become 10 liter minus 1 liter. What it will give? What it will give? 1 bar multiplied by how much? 9 liter. And then we know that the unit conversion, that is 1 liter is nothing but the 10 to the power minus 3 meter cube. Correct? Because 1 liter is nothing but the 1 decimeter cube, and then 1 decimeter is nothing but the, that means 1 decimeter is nothing but the 10 to the power minus 1 meter. So if it is cube, then it will become 10 to the power minus 3 meter cube. Correct? And then also, how we can write the 1 bar? 1 bar is nothing but the 10 to the power 5 Pascal. Correct? So how we can write this formula is like our calculation is 1 Pascal, that is 1 PA multiplied by 9. How much? 9 liter will be getting converted to the 10 to the power minus 9 meter cube. So this answer will become our how much? 1 bar is nothing but 10 to the power 5 Pascal. So here it will be 10 to the power 5 Pascal. So 10 to the power 5 multiplied by 10 to the power minus 3. What it will become? 10 to the power 2. So it will become 9 minus 9 multiplied by 10 to the power 2 Pascal. And then what? Meter cube. So it will become minus 900 Pascal meter cube. Okay, meter cube. And then we know that the 1 Pascal is nothing but the 1 Newton meter square. 1 Newton meter square. So if what it will become? Pascal suppose if you are writing 1 Newton meter square, so Pascal into meter cube will become how much? This is Newton per meter square. Okay, not the meter square but the per meter square. So what it will become? Newton meter square, and then the meter cube. So it will become what? Our Pascal meter cube will become what? Newton meter. So this is going to be our unit. That means 900 Newton meter. Okay, and then 1 Newton meter is nothing but the 1 joule. Okay, so here it will become minus 900 joule. And then now if you will see here like the work done here, what is asking? It is asking in the kilojoule. So if it is asking in the kilojoule, what it will become? Our answer will become how much? Minus 0.9 kilojoule. Correct? Correct? Minus 0.9. So option, which option is matching? Minus 0.9. Answer C is the correct answer. Okay. Now moving on to the next question. Moving on to the next question, just see. It is a little bit conceptual question. Like if you have understand what is really the work done, and like in the graphical format, so you will be able to solve this question. What does this question saying is the magnitude of work done by a gas that undergoes a reversible expansion. Okay, note it down. What is telling here is reversible expansion under the path A, B, C. A, it is starting from here, going B, and then stopping at C, shown in the figure is. So we know that the like in your NCERT textbook, you might have seen that the area is nothing but what? Area is nothing but what? Is nothing but the work done, and then it is nothing but the P delta V. And then suppose like if you will see here in your y-axis there is a pressure axis, pressure unit, and then here on the x-axis it is taken as the volume. Okay, and then one more like what you have to focus is on the origin. If you will see here, origin is 2,2, like it is starting from the 2,2. Otherwise, like you can make the mistake, many students make the mistake here only. Like they consider it as a 0, 0, and then here in place of 0, 0, consider 0, 0, and then they will here consider 8. But is it 8? No. This is, if it is starting from 2, then this is 6, right? And here also, how much this is? Not 12. This is your 10. And then this much. This is how much? This is 6. Correct. So here what we have seen that the area is nothing but the equal to the work done. So work done will be nothing but the area. Area of what? Area of trapezium. Area of trapezium, because here the mentioned structure is trapezium. Okay. So here our area, that means you have to find the area of this. If you will get the area of these, you will be able to find the work done. So how can we find out? Work done is nothing but the area of the trapezium, and then we know that the area of the trapezium is nothing but the of half of this A, and then this is your B. So this is nothing but the A plus B multiplied by height. Okay, this is your, like, if you want to find the area of the trapezium. So how much you will get the answer? Half A is nothing but the 6, and then plus B. What is your B? B is nothing but the 10. And then what is your height? Height is just 6. So calculate what work done you will get. What work done you will get? Half 16 into 6, 16, 6 and 96, and then you will get the 48. And then here, if this is like a 48, so what is going to be your unit? Just think. See here, like what you have seen. This is our x-axis, and this is y-axis, and then we are multiplying. So that means Pascal into meter cube. In the previous question only, like we have seen that the Pascal is nothing but the Newton per meter square, and then this is meter cube. So it is going to be Newton meter, and then Newton meter is nothing but the what? Joule. So the unit of this this question is going to be like answer is 48 joule. Okay, is it easy? Right, it is very much easy. Correct. So now moving on to the another question. This is also like a very much simple question. If you have studied, then you will simply just read the question and then tick directly. No need to like have a brain also if you will have the proper concept. Okay. So what does the question says? Which of the following are not state function? Okay. If you will think in hurry burry, you will read that it is asking about the state function, and then suddenly you will see the state function, and then you will do tick directly. But it is telling for not state function. Okay. So we know that what we know? We know that our state functions. What are state functions? State functions are what? Path independent. Okay, path independent. Handwriting थोड़ी गंदी है, please adjust कर लेना. So state function, it is telling about so state function is nothing but the path dependent, and who are all the state functions? Delta U is that is change in internal energy, change in enthalpy, change in entropy, change in gives free energy. All those values are what? State function, because they don't change, they don't depend on the path. So that is why this is the path independent. And then which are all the not the state functions? To not the state function, we call the as a path function. Okay, path function. What is your path function? Path function is nothing but the path dependent. What is your path function? Path function is your path dependent. So path dependent is nothing but the, or path function is nothing but the, that is your cube, and then the another is what? Work done. These two, just remember, like most of the time it asks, also it has been asked in the JE also, it has been asked in the NEET questions also, and then the other KCTs, and in the other exams also, it is going to be asked like what are the path functions, or what are the state functions. So here what it is asking? Not state function. So path functions are not our state function. So answer is Q and work, that is a heat, and then the work done. See, so this is our correct Q. This is also correct. Is this correct for H minus Ts? This is delta G, right? So delta G is our what? State function. And then Q plus W. Q plus W is nothing but the change in energy. Change in energy is also our what state function? So not a state function is 2 and 3. So which is the answer? Our correct answer is D, right? And easy. So now moving on to the another question. What does this question tell is if 100 mole of H2O2 decomposes at 1 bar and 300 Kelvin, the work done by 1 mole of oxygen gas as it expands against 1 pressure is. So ये दिया हुआ है तुमको. So ये homework है तुम्हारे लिए. This question is homework for you. Just try to note down the question. Just try to note down the questions and then just see, try on your own, like what the options you are getting. The hint, like if you want a hint, you can use here is, do you want the hint? It is telling about the work done. Work done is nothing but the minus P delta V, that is PV. PV is nothing but the, what we write PV? PV is nothing but the nRT, right? So what will be the answer? Minus work done is nothing but the minus PV. Instead of minus PV, you can write it as a minus nRT. Now just see how much number of moles of O2 gas you will get. Then R value is given. Also the temperature value is given. Okay, this is the homework for you. Now we are going to for the next question of 2001 of NEET question it is. So what does the question say is when 1 mole of a gas is heated at a constant volume. We have to like read one by one word and then separate the word. Okay, what does it telling? First of all, one word, underline the 1 mole of a gas. Okay, heated at what? A constant volume. Okay, and then temperature is raised from 298 Kelvin to 300 Kelvin. This is another point to be noted. And then what it is telling, if heat supplied to the gas is 500 joule, then which statement is correct? Heat supplied is how much? 500 joule. So what is going to be the answer? Just think. Let's solve. So what is it telling here? Then which statement is going to be correct? So it is telling about the Q, W, and then delta U. That is, if these three conventions are coming, that the heat energy, work done, and then the delta U. So that means here they are using the first law of thermodynamics. So what is our first law of thermodynamics? Delta U, that is change in internal energy, Q plus W. And then what is our work done? Work done is nothing but the minus P delta V. Okay. So just read the question once again. It is telling about the constant volume. What does it telling about the constant volume? Constant volume. If this becomes the constant, that is, if there is no change in the volume, so this will become zero. This will become zero, and if this becomes zero, then work done will become zero. That means this term will become zero, and then it will be Q plus U. So here we have the change in internal energy is nothing but the Q plus 0. So that means work done is going to be 0. In this whole option, if you will see, only one option is having work is equal to 0. That means our answer is B. You don't have to calculate for the others also, like just have a trick solve. And again, like if you are again have a doubt like on yourself, like whether my option what I'm getting is correct or not, calculate. What you will calculate? Heat is to the 500 joule. If this is 500 joule, that means delta U is nothing but the 500 joule. Here the same it is given here also. Q is nothing but the 500 joule and the work done is 0. Am I right? Correct answer right now. So now again, let's move on to the another question. What is your another question? graph. You are seeing the graph. So what you will think? Graph है tough रहेगा. It might be a difficult one. Okay, but this is believe me, it is not a difficult one. It is also one of the easy question of JEE which was asked in the 2019. So what does it telling? For a diatomic ideal gas in a closed system, okay, it is telling about the closed system. Which of the following plots, that means graph, does not correctly, here focus, it is telling about it does not correctly describe. It is not asking which are the correct. It is asking which are not correct. Describe the relation between various dynamic quantities. So it is, if you will see in the option A, it is telling the graph has been plotted against the CP. That is, what is your CP? Heat capacity at constant pressure. Against the pressure, then U internal energy against the temperature, and then the CV, that is your constant volume against the volume, and then the constant, sorry, not constant volume. This is what heat capacity. What is that? Does it mean? CV is nothing but the constant, sorry, heat capacity at constant volume. Here again, heat capacity at constant volume against the temperature. So let's go from the question number, like option D. Okay, we'll proceed from option D. What does the option telling is CV versus T? Does it have, like, we have any relations against this, like CVT? Yes, we have. What is the relation? What is the relation between the CV and the? We know that the delta U is nothing but the N CV delta T. That means if this CV, how we can write the CV? Can we write CV in this way? Delta U and the delta U and then the N delta T. That means if CV will change, temperature will change. Okay. But do we have the term volume here? Do we have the term volume here? No, we don't have the term volume here. That means it does not depend on the volume. Okay, it does not depend on the volume. That is, CV is independent of the volume. Okay, I mentioned here T word. Sorry, very sorry. Take it as a volume. So it is independent of the volume. So here our answer is, we can see that it is giving the straight line. That means it is not affected by the volume. So this is the correct one. Now moving on to the C, CV versus T. We have seen we have seen here only, your CV is nothing but the inversely proportional to the delta T. That means if your T will change, CV will also change. That means we can say that the CV is dependent. CV is dependent on what? T. If T will change, CV also, there will be variation. And in the graph, we can say that if the temperature is changing, CV is also changing. So this is also the correct. Don't forget, it is telling about the incorrect one, not correct it on the answer. Otherwise, you will see, oh, D is the correct answer, and you will tick directly. Right. Now moving on to the B. What does the B told is U versus T. U versus T. And we know that the delta U, that is delta U is nothing but the NCV delta T. That means if delta U will change, is directly proportional to the delta T. That means temperature is directly proportional to the delta U. If this one will vary, the another value will also going to vary. Correct? So this is our the correct answer. If all those three answers are, like, three options are correct, so which is going to be the correct option for us? Option A, right? So now see, like, how option A is incorrect graph. Here it is telling about the CP versus P graph. Okay, option A. We know that the formula delta H is nothing but the N CP and the delta T. In this formula, there is no pressure term. No pressure term. That means it is independent. Independent of what? It is independent of pressure. That means it should not change. That means CP should not should not change with respect to the pressure. That means the value we should get the straight graph instead of the increasing graph. That is why the option is the for us it is the correct option, but as it is asking the incorrect one. Okay. Now moving on to the another question. This is also one of the easy question. Like you might have studied the bond dissociation energy. Okay, and then okay, let's read the question. The bond dissociation energy of x2, y2, and then xy are in the ratio of 1 ratio 0.5 ratio 1. That means bond dissociation energy of what? X2, y2, and then what? Xy is in the ratio 1 ratio 0.5 ratio 1. And then what does it asking? Delta H for the formation of XY is 200 minus 200 kilojoule per mole. That means if XY is forming, if XY is forming, this formation of this XY is something but the minus 200 kilojoule per mole. Okay, and then it is asking the bond dissociation of X2, bond dissociation of X2. So if you want to prepare or we want to form the XY, you only think that the how we can prepare the xy if it is given x2 and then y2. If it is given x2 and then y2, what it will give? 2xy, correct? But it is telling about the formation of xy, and then like in the enthalpy of formation, like we have there is a definition. Formation of it should be how much? It should be for only 1 mole of the product. That means only 1 mole of the product should form, and then the enthalpy or the heat which is released during the formation of 1 mole of product is called as the enthalpy of formation. So, but it is here given is 2. So, what we have to do? We have to divide by 2. So, it will become half, and then also it will become half, and then it will give xy. And here delta H of formation of what? Xy given is minus 200. Okay, and also this is nothing but our what? Enthalpy of reaction. Okay, enthalpy of reaction. So you can see here is let the bond energy of x2 and then x2 y2 and then xy be the x. So our ratio will become 0.5 x kilojoule per mole, and then x kilojoule per mole, and then for x kilojoule will be for the x2, and then for y2 it is 0.5x, and then for xy it is x joule. So this is our reaction, half of x2 and then half of y2. It gives our 1 mole of the product for which it is given minus 200 kilojoule per mole. You have to remember here is enthalpy of a reaction. Enthalpy of a reaction is nothing but the here it is given minus 200, and then how we have to write the formula is nothing but the summation of bond energy of the reactant minus bond energy of the product. Correct. Like previously you have seen one more formula for the enthalpy of a reactions only. That is delta H is nothing but the delta H of formation of what? Product minus delta H of formation of what? Reactant. Okay, these both are different. This formula is different, and then this formula is different. So we have you have to be alert that while using the dissociation energy formula, you have to first write the bond energy of reactant and then the bond energy of the product. Now let's calculate on reactant. It is telling that is half. We have to take the coefficient also, and then for x2 it is x kilojoule per mole plus another half of 0.5x for y2. Okay, this is our reactant. This becomes our reactant, and then product is nothing but the 1 mole is forming. So 1 x is the kilojoule per mole for what? Xy. So if you will calculate, we are going to get the answer is x equal to 800 kilojoule per mole. So in this, correct option is option D. Okay. Okay. Now move to the next question of J 2013. What does it telling? Which of the following statements or relationship is not correct in thermodynamic changes? Again, what it is asking, it is telling about the not correct. Okay, you don't have to be confused. If you will see the right answer, like correct statement, and then you will directly take, but it is asking about the not correct. So let's see for option A. It is telling about the isothermal reversible expansion. Isothermal reversible expansion. And then you know that the if it is telling about the isothermal, that means if delta T is 0, it implies that the delta U is going to be 0. That means option is, this is the correct statement. Now, what does it telling? Work done is equal to minus nRT, natural log of V2 upon V1, and it is telling about the isothermal reversible expansion of an ideal gas. So we have this formula only, like for the reversible expansion of an, like at the isothermal condition. This is our formula only. So this is also the correct answer, where we write work done is equal to minus nRT, natural log of V2 upon. Now coming on to the third option, that is option C. It is telling work done is equal to nRT, natural log of V2 upon V1 isothermal reversible. It is telling about the isothermal reversible. But now only we see that it is formula is minus nRT. Okay, not plus nRT. So this is the incorrect option. So our correct answer is option C. Okay, and then what is telling in the option D? For a system of a constant volume, heat involved directly changes to internal energy. Yeah, this is the correct. If in the internal energy at constant volume, that means work done will be 0, and it is going to be Q. That is, change in heat is going to change the internal energy. So our correct option is option C. Okay. Now moving on to the again JEE questions of 2020, 2020. It has been asked, and if you will see these graph, like by seeing the graph only, you are going to skip the question, and then you will see like what it is given. I'm not understanding anything, or else like ये तो पढ़ा ही नहीं है, टेक्स्ट बुक में दिया ही नहीं है ऐसा कुछ. But this is also one of the easy. See, basic information you want. See, here it is given intermolecular potential energy for the molecules A, B, C, D are given. You can see here it is given potential energy, and here it is on the x one of the axes, it is given the interatomic distance. Okay, so here if you will see, A is having somewhat potential energy this much, and then this is the interatomic distance, and then AB is having the bond energy, that means the potential energy this much, and then having the atomic distance this much. For AC, this is this much potential energy, and then for AD, the bond length, we can say interatomic distance. Interatomic distance is nothing but the distance between the two atoms. Okay, so let's move on to the options. What is telling? AD has the shortest bond length, but here we can see that this AD molecule is having the larger bond length than the other molecules. Okay, so this is the wrong statement. AA has the largest bond enthalpy. If you will see here, does A has the potential energy? So this is also the wrong statement. Another is D is more electronegative than the another items. So no, D is not going to be the more electronegative, just because why? As it has the larger bond length. And then the another thing is AP has the stiffest bond. Stiffest bond, that means a strong bond. If the bond is strong, then the bond energy is going to be very high. Okay, so if bond energy is going to be very high, the potential energy is going to be very high. So here only AB is having this much of highest energy. So our correct option is option D. Okay. Now moving on to the another. This is also like a very formula based on questions only. Read it once. What does it telling? Lattice enthalpy and then the enthalpy of solution of what? NaCl are 788 kilojoule for lattice enthalpy and then the 4 kilojoule of what? 4 kilojoules of enthalpy of solution. So it is asking about the hydration enthalpy. In your textbook, clearly it has been mentioned that the what has been mentioned, delta of solution, enthalpy of solution is nothing but the enthalpy of lattice, plus what? Enthalpy of hydration, enthalpy of what? Hydration. So for solution, it is given 4 kilojoule, 4 kilojoule per mole. For lattice, it is given how much? 788 kilojoule per mole. Okay, so our hydration will be how much? Minus 784 kilojoule per mole. See how much easy question it is. Okay, recent question, just few years back only in the 2020, and then our correct option is minus 784 kilojoule per mole. Okay, and then the, like if I will say the trick, what I will say is hydration enthalpy is going to be always negative. Okay, hydration enthalpy is going to be always negative. So here if you will see, this is plus, so this is going to be our wrong. So answer is only two, A or C. You have to decide only between A and C. And here this is only formula. Just you have to do the, you should know the addition, subtraction, multiplication in this chapter. Okay, so our correct option is option C. Now moving on to the enthalpy change. Enthalpy change for the reaction. Okay, enthalpy change for the reaction is given how much? Minus 869.6 kilojoule. How much it is? 4 hydrogen. That is, it is a single hydrogen atom. Okay, so 4 hydrogen atom is getting converted to the 2 moles of H2 gas. That means 4 hydrogen is getting converted to the 2 moles of H2 gas. So there is a bonding, that is bond is forming between the H and H. So it is asking dissociation energy of HH bond. What is your dissociation energy? Dissociation energy is nothing but the energy to break the bond. Okay, energy to break the bond of how much? Of SH, H or H and H. Okay, energy to break the bond. But here we can see that the bond is forming, but we have to break the bond. How we can break the bond? Just reverse the reaction. If we will reverse the reactions, what will happen? What will happen? It will give 4H. Okay, it will give 4H. Then, if it will give the 4H, then if you will reverse the reaction, our enthalpy of a reaction is also going to be reversed. It is one of the convention. Okay, so enthalpy for this reaction is going to be how much? Instead of minus, it will become now 869.6 kilojoule. Okay, but this is for how much? 2 moles of hydrogen dissociation. But if you want to tell for the hydrogen and an hydrogen one, so we have to take for 1 mole, not the 2 moles. So what we will do, if we want to, if we will divide by 2, if we will divide by 2, what will happen? H, and then this will give 2H. So this is also going to be divided by 2. What it will become? How much it will become? 434.8 kilojoule. Okay, so our correct option is option C. Here also, like you have to remember, is for the dissociation energy is not going to be always, is not going to be negative, because to break the bond, if you want to supply the energy, then of course an energy, if we are supplying or we are giving the energy, it is going to be positive. So if you will see here, it is getting minus, so this is going to cancel, this is going to cancel. So you have to just select between the two options. That's it. And an easy question. So this is the another one. If the bond energies of the HH BR, and then the HBRR. So bond energies are given for you, HHBr, and then it is asking for the enthalpy of the reaction. Okay. So this is the another homework question for you. Note down the questions. Note down the question. This is another homework question for you. Try. Okay. Try the now change of minus 3 kilo at constant of what? Ethanol into what? Carbon dioxide and water. That means what? Your ethanol, that means is getting if you will do the combustion reaction, it will get converted to carbon dioxide and then the water, and then the combustion heat is minus 327 kilocalorie at constant pressure. It is given, okay, at constant pressure. So what will be the heat evolve in calorie? It is asking at constant volume. At constant volume and 27 degrees Celsius. If all gases behave ideally, R value is given 2 calorie per mole per Kelvin. You have to remember here is, if you are dealing with the joule, take the gas constant value as 8.314 joule per Kelvin per mole. But if you are dealing with the calorie, so take R value as a 2 calorie per mole, not the 8.314. Fine. So, so what it is asking, what will be the heat evolve at constant volume? So next, move on to the question. It is telling this is our ethanol combustion. That means in the presence of oxygen, we will get 2 oxygen gas and then 3 H2O water molecule in the form liquid state. We know that the delta this, if it is constant pressure is nothing but the heat at constant pressure is nothing but the heat. That means heat at constant pressure is nothing but the delta H, and then heat at constant volume is nothing but the delta U. So we have to find delta U, and then we know this formula, delta H is equal to delta U, and then plus delta Ng RT. Ng is nothing but the change in gaseous, change in moles in the gaseous. Okay, delta Ng. What is your delta Ng? Delta Ng is nothing but the moles of product, moles of gaseous product, minus moles of gaseous reactant. Okay, so here we are having 2 moles of gas, and here we are having the 1 mole of gas, so it will become 2 minus 1. Remember that we don't have to consider liquid or a solid or the aqueous phase. We only have to consider the gas. So delta U will become how much? Delta H is equal to delta U, so it will become minus 327. Why it is writing 10 to the power 3? Just because it is telling the kilocalorie. Okay, so it will become delta U plus delta Ng. Delta Ng is nothing but the minus 1. Minus 1. Why it is minus 1? It will be 2 CO2. Okay, this is going to be the 2 CO2, and then plus 2 multiplied by 300. 300 is nothing but the 27 degrees Celsius is mentioned. 27 degrees Celsius is nothing but the 3 Kelvin. From where 2 comes? 2 is nothing but the gas constant, and then this will become delta U is nothing but the minus 1. How it is going to be plus 1. Okay, so if it is the plus 1, so here what you are going to get the value is just calculate and then see like whether you are getting this answer or not. Okay, so answer is minus 326 400 calorie. Okay, now moving on to the Another question. Here it is mentioned that the three thermochemical equations are given below. This is the first equation, second equation, and then the third equation. And for all those reaction, enthalpy of the reaction is given. For this first equation, it is given x kilojoule per mole. For second, y kilojoule per mole, and then for third, z kilojoule per mole. So what we have to we have to give the relation between the x, y, and then z. Now, if you will see here is we are getting here is CO2 gas, and then here it is O2 gas, carbon, and then here we are getting the carbon monoxide. Okay, so how can we do? Suppose if we will add equation 2 and then equation 3, what we will get? C plus half of O2, it is giving us CO, having y kilojoule per mole. And then your third equation, that is CO plus again half of O2, what it will give? CO2. And then this is Z kilojoule per mole. Z kilojoule per mole. So if we will add this reaction, we can see that the C plus CO half will become how much? 1 O2 gas, and then CO plus CO2. Okay, and then here CO and then CO will both the sides will cancel, and what we will get is C plus O2. C plus O2 will give the CO2. And if you will see this reaction is nothing but the first reaction. Okay, first reaction. And for this enthalpy is given is how much? X. So from how we are getting this? By adding y and z. So x is nothing but the y plus z. So our correct option is option C. Right? Is it easy question? So now move on to the another question. Here it is asking the process with the negative entropy. Okay, negative entropy. Negative entropy, that means delta S is what? Negative. It is also the J questions of 2019. Dissociation of a calcium sulfate, which is in the form of solid, to give calcium oxide, and then the SO3, which is a gas. So A is nothing but the CaSO4 in the form of solid, and it is giving that the calcium oxide solid plus SO3 gas. So that means here from solid we are getting the solid as well as the gas. So whenever there is a phase transformation from solid to gas or liquid to gas or solid to liquid, that means entropy is increasing. That means from solid it is becoming gas. Gas is nothing but it is giving, if it is a gas, what it will give? It will give randomness. And we know that the randomness is nothing but the increase in what? Entropy. So here it is telling that the negative entropy, not the positive entropy. So this is not our option. And then sublimation of dry ice. Sublimation of dry ice, that means sublimation, that means solid will get converted to the gas directly. That means dry ice is nothing but the CO2 in the form of solid will give CO2 in the form of gas. That means solid is changing to the gas. Again, randomness is increasing because it is changing into the gas. If the randomness is increasing, then S entropy will also increase. That is, it is going to be positive and not negative. So this is our wrong. And what here it is telling? Dissolution of iodine in water. That means iodine is getting dissociated in water. Or we can say I2, which is the solid, and then plus in the water it is getting what? It is getting dissolved. Okay, this is getting dissolved. That means I2 I here will getting dissolved. That means the solid I is going to be in the form of what? Aqueous or ions. If the solid is changing into the aqueous and then the ion, that means randomness is increasing again. Okay, if the randomness is increasing, that means entropy is increasing. That means this is also the wrong statement. Like wrong statement, that means not the negative entropy. D. Now synthesis of ammonia from N2 and H2 gas. Like now we are synthesizing ammonia from N2 gas plus H2 gas. What it will give? 3H2 gas. Sorry. It will give us 3 NH3 gas. Okay, if we will balance the reactions, what we will get? Sorry, it should be 2 NH3. It will balance the reaction. What it will give? Here 1 mole of gas, here 3 mole of gas, and here 2 moles of gas. That means total 4 moles of gas in reactant is getting to form the ammonia, and then where we are getting the only 2 moles of gas. Only 2 moles of gaseous. That means gaseous concentration, or we can say quantity of the gaseous moles are decreasing. That means if the gaseous molecules are decreasing, that means randomness is decreasing. Randomness is decreasing. If randomness is decreasing, then entropy will also decrease. That means it is becoming negative. Okay, so our correct option is option D. Okay, now another question, what does it tell here is standard entropy, that is S naught, is given of the following substance: CH4, for CH4 this much, O2 gas entropy this much, CO2 gas this much, and for H2 gas this much entropy is given. Okay, so all those entropy is given, and it is asking for the entropy change for this reaction. So which is going to be the correct option is the formula for this is like, if you want to find the entropy change for the reaction is nothing but the uh, if you can write the entropy of what? Entropy of what? Product minus entropy of what? Reactant. Okay, so here what is your product? Product is nothing but the, you have to write entropy of CO2 plus entropy of what? H2O. Entropy of what? H2O. But here it is for 2 moles. So we have to mention here is 2 moles. Then minus entropy of 2 moles of entropy of what? O2. Then plus what? 1 mole of entropy of what? CH4. See, we'll get the answer is, we are going to get the answer. What answer we'll get here? Just calculate and then see how much answer you are getting. Simply that means what you will do is entropy of CO2 is telling CO2 is nothing but the 200.6 joule per Kelvin plus for H2O. So you will multiply 2 into 69.9. Okay, and then minus 2 multiplied by O2 gas. O2 gas is nothing but the 205.2 plus what? CH4, that means 186. Okay, so just see, I think you will get the answer is minus 242.8 joule per Kelvin per mole. Let's see, like 213.6 into 69.9 minus, you will get 410. So here you will get the answer is, yeah, correct. Option B you will get. Okay. So answer option B is your the correct answer. Now this is the last question homework for you. Just solve. Here what is given? Standard entropy of what? Standard entropy of X2 is given, Y2 is given, XY3 is given. That is 60 joule per Kelvin per mole, 40 joule per Kelvin per mole, and 50 joule per Kelvin per mole. So for the reaction, this reaction is given, and for this reaction, it is telling delta H. That means enthalpy of the reaction given is delta H is equal to minus 30 kilojoule. Okay, to be at the equilibrium. Okay, it is asking the how much temperature it will be. Shall I give the formula? Will you calculate? See, if it is equilibrium, we write the answer like delta H minus T delta S. Okay, So if it is telling about the equilibrium, if it is equilibrium, then delta G is nothing but the going to be 0. So this will become 0. And then delta H is enthalpy of the reaction, which is already given. And then you have to find what? You have to find T. And then the delta S. Delta S is given for you. What is going to be the change in entropy? Delta S is nothing but the change in entropy. Change in entropy is nothing but the, it is going to be what? Entropy of product minus entropy of what? Reactant. Okay. So try to find the answer, note the questions, and then okay. So thank you everyone. Keep solving the questions, and then how much ever is like the much questions you will solve, the much expert you will become in this. Okay. So bye bye. Thank you.